All right, where were we at? Right here then, kids, pretty much? Right down here?
Yeah.
So we got through this right here. We got through part A right here yesterday.
Yeah.
When we sketched this, we said this was going to be a parabola. What effect did timesing by 3 have on your parabola then yesterday of your parent function? Yeah, it was.
Juniors with last name starting A through L, you can report to the auditorium for pictures.
Yeah, it was a.
Juniors with last names A through L report to the auditorium for pictures.
So it was a vertical stretch. And which coordinates are you stretching? Are you stretching the x coordinates or the y coordinates?
Y.
Always stretching the y coordinates there, okay? Always stretching the y coordinates. So now I think the one that's kind of tough right here is B. I want you to put a star by this one right here and talk about this. I'm going to graph the parent function first. But I think that the question we need to ask ourselves is, first of all, what family is this going to be in part B? Which family is this going to be in part B? It's going to be an absolute value, okay? So I'm going to jot this down right here. The family of this is going to be absolute value. So let's talk right here. Okay, I'm going to draw the parent function to this. So a parent function for absolute value is going to look like this. Do it this way, kids. Okay, so absolute value is going to look like this. This is the parent function to start with. All right, so let's talk about what the parameters on that absolute value function do here first, all right? I'm going to kind of cover up the 3 here and just look at this right here. Look at the 4 right in front of the absolute value. What's that going to do first? It's going to stretch everything by how much? 4. What's this negative going to do? Flip it and then do what? What kind of 3 is this really, kids? Not left. There's no parentheses, so it would move it up 3. So let's think about this, kids. We have a vertical stretch of 4. We're going to flip it and then move this up 3. So I'm going to kind of go with points right here, okay? I'll use a marker on this here. So if you can kind of follow along on this. You guys agree that this is the point 0, 0 right here, right? Okay, help me out. Take 0, 0 times that negative 4 first. What would 0 be times negative 4, kids? 0, and then add the 3. Where's that put you at? Puts you at 3, doesn't it? Okay, so we're going to have a point here at 3. Okay, let's see if we can't figure this out. I'm going to kind of cheat on this a little bit. Is that okay? Show you what's really going on. What's the y value right here? 1. So take 1 times negative 4, kids. What is 1 times negative 4? Negative 4, now move that negative 4 up 3. Where are you at? Negative 1 right here. I want to show you something real quickly. Okay? We've taken this vertex at 0, 0 and moved it up to 0, 3. Guys, from the 2 points that I've put on here that are new, what's the slope between those 2 points? Rise over run. What's the slope between those 2 points now? Negative 4. Doesn't that kind of match that value right there? Okay. So is this going to be a V shape or an upside down V shape? Upside down V. So once we know one point over here, we kind of know the other one, which is going to be right here. Once you have basically 3 points, you're just going to draw your new V, all right? And here's what it's going to look like. I think it's always important to say, okay, what do these parameters do to my original graph? I think, again, if you can answer these questions. The negative flips it. The 4 is going to stretch everything. I think about your y values here and get a few points to start with. We started with 0, 0. We multiplied by negative 4. That was still 0. And then added 3. That puts you up here at the vertex. We took this y value of 1, multiplied it by 4. That got you, multiplied by negative 4. That got you negative 4 down here. And you moved it up 3 more units, put you here. You know it's going to be a V shape somehow because the parent family is an absolute value function, so that's how you do this stuff. Okay? How do you guys feel about that one? Okay? Thumbs up, I like it. Good, good. Well, let's run into the last page, and I tell you what, I'll give you some time to work on some things that I want you to get done for Monday. So hopefully we can have plenty of time to get things done. Last page, kids. Here we go. I screwed up here a little bit. You might want to make sure you understand this 2 right here was supposed to be an exponent. So this should be h of x. Whoops. This should be h of x equal to negative 0.25 x squared plus 4. Okay? That's what that should be right there. Already done? Are you guys field trippers today? Are you?
Yeah.
Have fun on the charter bus. Did you see that out there?
The bus is like, everyone's on the bus. I'm not even ready yet.
People are on the bus?
No, it was a joke. She was on the phone and she was like freaking out.
And I was like, we're on the bus, we're waiting. Doesn't hurt. You can put your bag in here.
Yeah, can I leave my bag in here?
Sure, absolutely. Just leave it back there. That's fine. Okay, I'll wait for the fashion police to vacate, and we'll get going on this last page. You guys all good then?
But I'm also wearing jeans.
Should I bring a sweatshirt?
I will.
Decisions, Gabriel. Decisions. Okay, everybody back up here. It says in number 5, use a graphing calculator to sketch h of x.
Teachers, please release the students going on the UNI trip. Teachers, please release the students going on a UNI trip. And students, make sure you put your bags and everything in your lockers before you leave.
It says h of x equals negative 0.25 x squared plus 4. It says, first of all, tell me a parent function. What's parent function going to be of the 4, kids? Is it constant? Is it linear? Is it absolute value? Or is it quadratic? Quadratic. What makes it quadratic, kids? What makes this function a quadratic function? Yeah, the squaring part does up here, okay? So let's pop this into decimals real quickly. You don't need to open that up there, so let's see what I can find. Decimals, the most beautiful calculator in the world. Oh, Rhett, will you read that function to me again, please?
H of x equals negative 25 x.
Is it negative 25 or negative 0.25?
0.2 x squared plus 4.
Okay, first question. Does it look like a U shape? Originally, the parent function was a U shape. Okay, just flipped over. It's an arch now. Okay. So what they're asking you guys is describe the transformations. Okay.
Can I leave my bag in here?
Sure, just put it in the back corner. Okay, V. Have a good weekend. Okay. How does this transform then, kids? I'll tell you, there's 3 different transformations. What's one? What's one movement that happened to this right here? In fact, maybe I should go back to decimals and put my parent function in here. My parent function would be y equals x squared. Okay? And we wonder how Under Armour got its logo. What's one move that happened from the blue graph to the red graph? What's one transformation? It flips, right? Is that what you said, Sterling?
Yeah.
Yeah, it flips. Okay? So one transformation is a flip. Okay? The flip happens because of the negative out here. Okay? Hey, we're taking x squared times what value, kids? Taking x squared times what value out there? A quarter, 0.25. Is that value more than 1 or less than 1? It's less than 1. So is that a vertical shrink or a vertical stretch, kiddos, if it's a factor of less than 1? Is that a shrink or a stretch? Less than 1. It's a vertical shrink, yep. So that was this part. The vertical shrink was this part. And then there's one more part to this. What's that plus 4 doing then after it flips it and shrinks it? Well, it's adding 4 without parentheses do. Anybody? If you're not sure, look at your cheat sheet. See what adding a value does, what direction it moves stuff. Moves it up. It would move horizontally if there were what, kiddo? Parentheses. Very good, Rhett. Okay. Yeah, this +4 is going to move this up 4 units. I want to show you. I want you to see this transform real quickly, okay, kids? Okay, so you have that in your notes. Here's what I want you to see, okay? I'll move this over here. All right. Which one's the parent function, the blue one or the red one? Blue one, okay? Watch what happens right here, kids. I'm going to throw the negative out in front right here, okay? What's the negative do first of all? Again, so it flips it, right?
Yeah.
Flips it down, okay? Then there was a negative and this became 0.25. So this 0.25 is going to take this and then it's going to shrink the y value. So watch where this y, see where this y value is right here, kids? Watch this point right here, okay? Everybody see where I'm at? -1, -1. Watch where this point goes when I multiply by the 0.25 in here now. It went from -1 and it shrunk closer to the x-axis, okay? And then what's the last thing I need to put on the end here, kids? That's going to take this and it's just going to move it up 4 and it puts it right on that line. That's how that's transformed, okay? That's how that's transformed. Okay, so I would always encourage you, if you're going to use decimals to validate what you're doing, start with your parent function, put your other one in there, and then with your parent function, just kind of start typing stuff in to visually see what happens to the graph when you start applying certain parameters to your equation, like a negative sign, or a factor, or adding something, or subtracting something. I think that this is a great tool to visualize what's happening. Okay? Questions on example 5 at all? Going once. Going twice. Let's get this last one done and we'll get you rolling today, okay? I like this problem. How about a volunteer to read this for me?
The table shows,
Thank you, Annika.
The table shows how many miles y you are from home after X hours. What type of function can you use to model the data? Estimate the distance after 4.5 hours.
Okay, help me out. What does this look like graphically? If I start plotting these points, I'm just going to make a sketch of this. What's the first point that's really up there, kids? What's the first point that's really up there? 1 comma 50. And then it goes to 2 comma 90. So if I had to sketch, maybe 1 comma 50 is here. Okay, 2 comma 90 might be about here. What's the third point? 3 comma what?
130.
3 comma 130 might be right about here. What happens at hour 4 then? It doesn't continue to increase. Instead of going from 130 and continuing to increase, what's it start to do?
Decrease.
Starts to decrease. So this becomes back to 90. Oh, at 5 hours we're at about 50. Ooh, what kind of graph does this appear to be, kids? Yeah, I think the family of this is, and I'll abbreviate right here, I think this is an absolute value function. So they're going to say, hey, if this is an absolute value function, from hour 1 to 2, didn't the distance go up by 40 miles? And from hour 2 to 3, didn't it go up another 40? And then, kids, it looks like somebody turned around because all of a sudden, what's happening to your distance from hour 3 to hour 4? Goes back down to what? 90. Goes back down another 40 miles, another 40 miles. The question becomes, what's a good estimate for the distance after 4.5 hours, kids? Well, wouldn't 4.5 hours be right in the middle here? So what's right in the middle of 90 and 50? 70. So a good estimate would be 70 miles at 4.5 hours. Okay, so again, what family does this data appear to be? It appears to be an absolute value family. It says the table shows how many miles, y, you are from your house after X hours. What type of function can you use to model the data? Absolute value. If we know what's absolute value, then we can kind of look at this right here and say, well, absolute values are linear on both sides. So we can say, well, 4.5 is right in the middle of 4 and 5 hours. That means 70 is right between. So you're about 70 miles from home after 4.5 hours. Okay?
Junior's last name starting